Network analysis theory. I guess that sounds worse than it really is. The first section that we'll talk about today will give you the building blocks onto which we'll base further learning about protocol and network analysis. The topics we will cover include the numbering systems and the units used for analysis, and some numeric conversions. We'll then go into greater detail about the 7 layers of the OSI model, and protocols and protocol stacks in general. Within networking technologies, there are 3 main numbering systems in use. We're familiar with the decimal or base 10 system with digits from 0 to 9. The hexadecimal, or hex codes as we sometimes call them, use base 16, with digits from 0 to F, or 0 to 15 in the decimal system. And, of course, the binary system, or base 2, with only the digits 0 and 1, or sometimes referred to as on or off. The ability to convert within these systems is sometimes necessary within packet capture and protocol analysis, especially in building advanced filters. Luckily, we won't spend much time on decimal math, but we will examine the hexadecimal and binary systems in more detail. In hex, the first thing to note is that a string is identified with a 0x prefix. For example, 0x123abc974 would be interpreted as a hexadecimal number. Converting hexadecimal to decimal is a simple matter of multiplying each hexadecimal digit by its place value and then adding the results. Binary numbers work on the same principles as decimal or hexadecimal numbers, and are usually preceded by a percentage sign to designate them as binary. For example, percentage 101 is not 101, but must be converted, remembering that in binary each place is a power of 2. Here we have an example of converting binary to decimal. A byte is 8 binary bits, or 2 hexadecimal digits, or 2 nibbles. Therefore, 1 nibble is also equal to 1 hexadecimal digit. Converting binary to hexadecimal is a little bit more complicated. When converting binary to hexadecimal, first divide the binary byte into 2 nibbles. Then we assign the least significant bit in each nibble to the ones place. Next, we convert each nibble to its decimal equivalent, and finally, we convert each nibble to its hexadecimal equivalent. Reverse the procedure to convert hex to binary. Network analysis deals with the common number prefixes used when the numbers are very large or very small. For example, gigabit Ethernet or microsecond responses.